In this video, we're going to be considering flight. Now, the ability to take off and disperse through the air confers all sorts of advantages on an organism. And there are two types of getting into the air. There's the gliding and powered flight. So with gliding, we have things like the flying squirrels and the things called flying lemurs, the colugos, sugar gliders, which are our marsupial from Australia. There are flying lizards, Draco, which use their rib cage as wings. And there's even the flying snake. Not only snakes and other animals, but also plants use it. Sycamores and dandelions use unpowered flight, gliding, to get away from things and to find new areas to colonize. And even spiders, some baby spiders, let out a small section of silk which catches the wind and they disperse by air. But powered flight has evolved only 4 times in the animal kingdom. Well, 5 if you include the squid. For very small parts of their dispersal, squid launch themselves out of the water and eject water from their siphon and spread these fins at the front of their body and glide for distances. So that's a bit of jet-propelled flight. So possibly 5 times. But traditionally, the idea of powered flight has been using wings and muscles. So here we have a series of starlings showing the flight stroke, because flight is not just beating your arms up and down, but pronating and supinating, so you get airflow to provide lift and thrust. And so for powered flight, you need 2 things. You need a very large surface area. So this is the wing of a heron. And you also need to cut down on weight. So all birds are light. If the heron to whom this wing belonged to was perched on my arm, it would feel very light indeed. And some of the smaller birds you barely notice when they land on you. Even an eagle owl or a golden eagle, when it's on your arm, feels incredibly light compared to the size of the bird. And birds have done this by reducing their skeleton. So they don't produce teeth, and their bones, of which there are a large number, just as what you'd expect from a vertebrate, are hollow. Not only does this cut down on the weight of the bones, but also the hollow bones are filled with air sacs, which are used to increase the rate at which air passes through their bodies. So they are always extracting oxygen from their lungs, and the air sacs are pushing the air through their bodies. But birds aren't the only things that can fly. We also have the first creatures that flew, the insects. And here we have a series of locusts, some with their wings folded and others with their wings outstretched. And as you can see, from the animal when it's not flying, the wing area, this huge acreage of flight membrane, is tucked away and folded so it's kept safe and out of the way. But when they do take to the air, they beat their wings and they fly very vigorously, and you don't want to be caught in a swarm of locusts. Of the mammals, the only creatures that have true powered flight are the bats, such as this one here. And bats, like birds, have modified their arms to support the flight membrane. In birds, the flight membrane, the flight surface, is created by using feathers, which are outgrowths from their arms, from their skin. And this beautifully asymmetrical feather shows you that this is a feather that's used for flight rather than a feather that is used for contour, to give shape to the bird, or for display. The asymmetry means that it doesn't rotate in the socket that holds the feather onto the wing and allows them to generate enough force to keep them in the air and get them into the air. Bats flap their arms, and between the digits of their arms they have these wing membranes made out of skin. And bats are very successful. There are an awful lot of them, lots of different species, including these small microbats, but there are also the megabats, the flying foxes. Where animals are not needing to fly, either to disperse or to find food or to escape predators, animals will lose the power of flight. So this brings us to the kiwi here. And the kiwi, though still covered in feathers, none of them are asymmetrical, they're all tatty, and their wings have become vestigial, they're very tiny. Same is true of these insects. The ancient stick insects had flight, and some of them still can fly, but these ones have lost the power of flight altogether. The last group of creatures that flew are now all extinct, and these were the pterosaurs. Pterosaurs are a group of reptiles, and they flew in the ancient Mesozoic skies in the same way that bats did, so on a membrane extended from their from modified forelimbs, their arms. Whereas bats use all of their digits except for the thumb to support the flight membrane, the pterosaurs just elongated the fourth finger, so they kept their thumb and the first two fingers free, and the fourth finger, the ring finger, was greatly elongated, and that was the one that supported the flight membrane. They're sadly all extinct, but there are a large number of them in the fossil record, ranging from these ones, these small Pterodactylus, to this large one, which is Tapejara. Tapejara was a South American, and you can see this huge elongated fourth finger on which the flight membrane was connected to the body and to the rest of the arm. The largest of the pterosaurs were so big that when they were on the ground, they would be able to look a giraffe in the eye, creatures like Quetzalcoatlus. What something like that has to go through in order to fly is incredible. But that is why we understand that flight is so important, that all these adaptations are worth it. These hollow bones, producing these feathers, having a good visual system, the importance of getting away from predators, for dispersal, for finding new things to eat, are so critical that flight is integral in the animal kingdom.